Hello everyone. Yeah, what follows is a short video of me repairing this Rohde Schwarz generator. There's lots of soldering and general interest. Pretty boring really, but if you're interested in how it was fixed, then carry on watching. If not, there's just the intro saying that I fixed it in case any of you were curious. So here it goes. Enjoy or not. Well, here she is. The good news is that she's fully functional. Lovely. What did I have to do? Repair all those cables and all those ribbon cables as you saw and put it back together. And that cap there had blown its top. That was well buried inside the unit actually. It's not easy to see until you start taking everything apart to get to the cables to repair them. You could tell that the lid of that capacitor was dislodged. So I changed that, put it back together, and there was quite a bit of hum on the power supplies, and I had to set up the power supplies. The manual is on the internet. So just went through the power supply and changed a couple of more capacitors and a bad joint on one of the regulators, and then it sprung into life and it's been working fine. And I've got it connected up to the you can see we're set on 1.3 megahertz at the moment at minus 50 dBm out of the sine wave output at 50 ohms, and there it is. Minus 50.2, 50.4 on the indicator and 1.000 megahertz. So we've got a 2021 piece of test equipment here in the Siglent spectrum analyzer, and a 1996 version. I'm not even going to bother calibrating it because it is absolutely spot on. I'll just set to another frequency and you can have a look. Let's set it to 100 and hit the kilohertz button, and then go over to here, frequency 100 kilohertz. There you go, look at that. Same output level down there, 100.000 kilohertz. So 1996 piece of equipment. Probably I couldn't see any calibration stickers on it, but the other one was the same. You don't need to touch them. They are absolutely amazing generators, and if you want to, you can go down to 1 hertz. So, oh yeah, and the other thing I had to do is I'll just turn this off. Let's kill that. Is the fan vibrates on these on a kind of a springy mount look, and they jabber and whir all over the place. So in the end, I discovered that the top part of this is copper, so I put a large solder blob on there. You can see it with my finger is, and adjusted the size of this blob until it was balanced much better, so the fan was much quieter. But otherwise she runs beautifully. Very good piece of kit. The control works, and you can set to vary the frequency here or vary the level there. Lovely piece of kit. GPIB signal generator, all repaired. Wonderful. Transformer's loose on the bracket. I must disassemble the old girl, and time to tighten her up. Oh, nice and tight. Right, okay, first thing, the original patient zero was this switch. Doesn't latch, look, so let's give that a bit of a squirt, shall we? Get some juice in there, the old WD-40. Make a lube her up a little bit. There we go. Now she's latching, look, see? That's all she needed. That was all was wrong with it when the guy originally had it. Maybe there was other faults on it as well. Might be unfair. Right, okay, so let's solder her back up. Let's turn the soldering iron on. Ooh. There we are, lovely. Beautiful. Right, number one. Very hard, very stiff wire. It's awkward stuff. I have to locate my actual wire strippers at this rate. There we go. That's grey. Where's his counterpart down there? Yeah, I might as well just replace that piece of wire with a piece of wire. Is that the one down there? No. Oh, there's the blue one, look there. There she blows. Let's go right on this one. Oh, lovely. Right, there we go. Lovely. Smoky. I wonder if I can just shorten those. No, I don't think I can. Sleeving job in it. It's going to be sleeving and strippers. I love strippers in the morning. Oh, fuck's sake. That is a lovely job. I think so anyway. It is the original transformer. It crossed my mind that someone might have just ripped it all out because they wanted to swap out the transformer, but the actual wire, the way the wires are cut and snags and the angles all match up. So, you know, where you can see that they were part and parcel of the same device. So they have just been cut with a view to disabling the machine rather than changing the transformer or robbing parts from it. I think all the parts are original actually. And the ribble, right, which one's the white one? That's the white one that goes on there. But I'll do the black one first. Get on that, thank you. And then the white one. It's a mite awkward. Alright, okay, bend those round a bit. They are going to be absolutely fine, I'm sure. They're looking lovely. And now where is that plastic cover that I took off? This is the problem. So, a plastic cover that goes over the top of the switch. I think that's fixed. Yeah, so that's the wiring, the input wiring to the transformer, and I think there is one, yes, there's one that's been snooped on right at the root, look, there it is, the yellow wire. These things have got specially screened capacitors, which I had to import some for my other generator, because one of them, well, I was using it one day and it just went dead. And the capacitor gone short. I think there's a video on the channel actually. I think I recorded the repair of it. So you can see what a working one's like. Oh, and you can see how accurate it is as well, because on the other video, I was testing it with the HP counter timer, accuracy and output voltages and so on and so forth. Right. So what's this one here? Look, if we zoom in on this, you can see there. Look, it's been diced down there. The white wire. White wire has been bugrified. Has it actually been cut? Where's my scalpel? I don't know how they make these so accurate, these things. I mean, I do and I don't. You know, I think when I was testing it at a megahertz, it was 1 hertz out according to the HP analyzer. So They do a good job, these blokes. There we are. Going to fully sever this wire because it's... Can you see that? Can you see that? Okay. User. Yeah, you can't win. There we go. Lovely. Bit of sleeving on there. Don't want it clenching up, do we, before it's ready? It's a bit nice and relaxed. Take it by surprise. There we are. Lovely solder joint, that's not going anywhere. Clean your tip. So we've got our transformer, it goes around that way, just like that. That's not part of this. Anything else we missed? Anything we missed? Can you see anything? Right, so that's all reconnectorated now, I think. And that one hasn't been cut. Alright, okay, so let's just plug that one in a bit further. Now, rather than having that rattle around, I might as well bolt it back in, and I think. Yes, I had. Where's the screws? Yeah, on the back of this thing I can see a voltage setting plug. It's one of those square voltage selectors, and it goes 100, 120, 220 and 240. So it hasn't got 257, which is what it is most of the time in my house, because of the bloody poles that go down the road. Not the Polish poles, but the wooden poles with cables on the top. They go for miles down the road, those things. One guy turns his tumble dryer on and the other one's iron long stops working next door. Still, shouldn't be phased about that, should we? Right, so that's that bit repaired now. So we've done a minute to snip and then 20 minutes to fix. Right, I'm gonna have a cup of tea. Well, there we go. Let's turn that down a little bit. That's better. Yeah. Okay, so what have we got here? Time to retire these cutters, I think. They're getting a bit blunt. Very, very stiff, horrible wires. It must be the heat proof. I'm not quite sure what it feels like. It's PTFE. PTFE. Right. I'm filming. Right. Now there's two green ones. Look, there's that green one there that's been cut at an angle. Can you see that? Lots and lots of wires that are made of steel. It's bloody like a hose pipe after it's been in the frost. Right, there's two green here. I'm gonna have to make sure I put the right. I don't think they're probably the two greens here are the same part of the same winding. So I suspect all I need to do is just connect them up, but I do know which one went where because one's been cut at an oblique angle and the other one hasn't, so I should get it right. If not, we'll find out. We don't have any magic smoke out, do we? Actually, it's not magic smoke in Transformers, it's horrible smoke. Okay. Green, obliquely cut greens, that one. And which one of these two? That one. Belongs on that. Actually, I wonder if they're the same at the end of the winding. I expect they are. We'll soon find out, won't we? Come on, baby. Lovely job. Brown, I missed the brown one, look. Oh look, there's two purple as well. So which one's which? I think I've got the purple ones around the wrong way, don't you? Because that's long and that one's short. So I'm going to have to remove this purple from here. and whop it onto this one. Don't be afraid. The long and the short of it is, you can guess which is which. Interesting. Don't really see a black one there, do you? I'm leaning over so you can see what I'm doing, so consequently I can't see what I'm doing. You see what I mean? That makes sense. Just smoke. Blub blub. Horrible wire this. I don't understand why they used it, but it's quite expensive PTFE cables. I used to work on aircraft instrumentation and flight computers, and they were all wired up with this stuff. I suppose it swings and roundabouts. It's easier to solder them because the insulation doesn't shrink back, but it's much harder to strip them. Right, what have we got? We've got the black one. Come on, up you come. Line yourself up nicely, come on. Has that been cut through there? No, that's just a nick, I think. Yeah, that's just a nick. It'd be a bit of a nightmare if you're colour blind, wouldn't it? Interesting, when I was 16, they said the careers person saw me and said, what do you want to do with your life? I said, I want to do electronics. And their biggest concern was, are you colourblind? They gave me a colour blindness test because that was their sum total of their consideration of whether I was suitable to be an electronics engineer or not, which I thought was interesting. Right, that's a lot in it. Can you see any in there that aren't joined up? Don't think there are. So let's sleeve the babies up. Slide it over. Do you know what? I might fire up the blower for this, seeing as there's a whole bunch of basically a group shrinking party to be done. That dinging is my kids have gone Christmas shopping and they're sending me pictures of things I think they think I might like for Christmas. So they've left at the last minute, but almost. Come on. Is that one badly arranged? Yeah, it is a bit actually. Let's just straighten you up. Come on, that thing. No one said it was going to be easy. Come on. gone a bit sphinctery. It's folded in on itself. Right, the red one. Ooh, that's been nicked there, look. It's only a nick though. Let's put a bit of insulation over that. That won't reach, will it? I'll just put a bit of Kapton tape on that one. Actually, look at that. Haha. Serendipitous. I put 2 pieces of sleeving on that one. Lucky happenstance. Brown one, green one, in between one. Slide it up the hill. Right. Okay, are we all in position? No, we're not. We've got one. Ah, that's why that's got 2 pieces of sleeving on it, because that one's only got none. So, I'm going to add a bit on this one. Here we are. Lovely jubbly. Right, let's have a bit of a shrinking session. Right, so I'll just give it a bit of a toast. I love doing this. Take it all. There we go. And that one must go over there. So that, apart from the screen winding wire, the yellow and green one, or the green and yellow one, whatever it was, they're all connected back up again. And the power switch is connected, so we should have some, oh, look at this. Got a broken thingamy here. That is the fan speed wire, isn't it? Fan control wires. 3 of them. Look at that. New PTFE as well. You bloody well are and all. Just going to shorten your sleeving on that bit. Going to use a big bit of sleeving over the outside. And then 3 small bits of sleeving on the inside. Double sleeve. Is that going to be long enough, do you think? I don't think it is it? I'll take that off a bit more. Oh. I think this is the difficult bit actually. I think the rest of it's going to be pretty straightforward. Certainly the most awkward bit, and ribbon cables I don't think going to be too bad, he says. Connecting up the fan. There we go. Two, three. Right, go for the brown one first. And then the yellow one. There's no pink one, so there's no dilemma. Go. Turn the blower on, get some heat in it. Okay, so that's the fan reinstated. Let's plug her back in. Surprisingly weak connection really, just a pin header. Low locking, no keying. There we are. Oh look, looky. Oh, can I turn this round so you can see this? Look what's lurking down in the depths of her despair. There she is. Whoa. Yeah, that is a definite exploded capacitor, isn't it? Aluminium electrolytic. Anyway, that's going to have to be looked into. I don't know if we've got a service manual for this. What's the component reference on it? Is there any number on it? No, I'm going to investigate this component and come back to you. Right, I had a look on the schematic. Fortunately, I have got the schematic for this thing, and this is a decoupling capacitor. I'm not sure about what the voltage on the rail is because it's in there somewhere, but I haven't bothered. It's one of those scans of a PDF rather than the proper PDF, so it's a bit fuzzy to be honest. And anyway, it's 100 microfarads, and I haven't got any nice 100s, but I've got some very nice 47 63 volt from Rubicon, and so I'm going to put one of those in. In fact, I'm going to put two of those in, coupled together like that in a little tandem pair. Didn't find the can rattling around in the box either, because also the can's blown off. Let's have a look, see if we can see what the polarity is supposed to be on this. Get the dirt off it. You'd think they'd tell you, wouldn't you? It doesn't cost anything to put a little bit of screen print or even screen on there. So this one's going to be, this is the 0 volt connection on the left because it's actually connected straight onto the ground plane. So I might as well give her a bit of a suck while I'm at it. I found a date, 1992 on this. I don't know if that's true, or that's just a coincidence, when it was last serviced or whatever. We'll find out, won't we? Yeah, this is connected to a regulator chip here via a fuse, which I presume is somewhere on the power supply board, which may have blown because this capacitor has gone. Not sure. Right, so negative, positive, long weed. Get rid of the crap off there. Make sure no shorts. Might take this down the shed and workshop and blow it out. Here's the EEPROMs. Look, they're not EEPROMs. They're basically, to erase these, you have to take the label off, expose the window, and put them in ultraviolet, and the ultraviolet will discharge the actual gate of the memory cell. And they also discharge from general leakage and also cosmic and solar radiation. So to erase them, you put them in a UV field, but hopefully they've still got their data in. If they're not, I'll have to take the ones out of my other machine and get them copied My friend's got a EEPROM blower. I haven't got mine anymore because I don't use them very often. They used to be everywhere in electronics factories, virtually everything, even the BIOS on the PC was the old PCs, CPM PCs were put in with these things, hard programmed. That plug is out, look. Ah, that plug is out. I'm going to push that back in. There we are. And that one. Don't think I've done that. I think they weren't in properly. Who knows? What's this for? Oh, here they go. It's the sweep output voltage. Okay, Shreddy. Does that reach down there? It does, yeah. I might as well just put that back on, hadn't I? Okay. So I think that is essentially everything on the front panel repaired. So, oh no, this ribbon. What we're going to do with the broken ribbon? That's the question. What we're going to do with this? Oh, cup of tea's arrived. I'm just scoring the insulation here. I'm not going, hopefully, through to the wires. I don't know if it's going to work. This is the voyage of discovery. I never had to do one like this before. We should tele-macro this, shouldn't we? Right, okay, now look what we've got there. Well, you can't see what we've got there because it's bloody shifted all over the place. There you go. Now then. What we need to do is just overlap them like that and then straighten them out like that. And yes, you guessed it, put some flux on. Keep those nice and aligned. Little behave yourself, you bloody things. Right, I think what I'm going to do at the moment is put a bit of temporary Captain on, and then when I've soldered these with the help of some flux, naturally I'm just going to encase it in a little rivulet of epoxy, and then I'm going to have a cup of tea. I'm going to drink my tea. Right. Okay, so numbers. I'm expecting a lot of shrinkage on this. So now, we don't want any oxidization of our solder, so we're going to put a bit of flux on, otherwise it will drag, and then when it drags it'll bridge across, so we don't want to do that. I'm going to put some nice bit of blobby on there. Things go better with flux. It's not actually Coca-Cola, it's flux that things go better with. Number one. What solder on number two? Number two. Number three. Number four. Can you see what difference a little bit of flux makes? It's lovely, isn't it? Don't you just wish you had some? I love this. Love the precision stuff. It makes me feel precise. Right, I think what we're going to do, rightly or wrongly, put some more flux on that one. I'm going to do this one by hand rather than holding it in position. Put some of the bit of starters on. Right, so we're just going to tin them up. When you get your iron down to a slightly lower temperature, you can deposit more solder, which is nice. Oh, look at that one. I'm going to straighten that one out. There we are. That's the M1 done. What is going on with this thing? Alright, a bit more of the old flux. Now, can you see whether we need any alignment up there or not? You can't, can you? Right, here we go. Actually, I'm going to poke, there's a little wire poking down there. It just needs a little bit of a lift. There we are. Lovely. Oh no, I bridged it. So I bridged it, so we're going to put a bit more flux on, because you can never have too much flux. And then lift it off. Maybe just give it a bit of a tap. No, it's not going to work either. Come on. There we are. Lovely. Be more careful. You've got to be more careful. There we are. Just that final one to do. All right. Let's just check the integrity of that one to make sure it's soldered on both sides. Yes. Yes, that's how you do that, boys. Now I'm going to give it a quick wash. I think I might be able to see a bit of a potential short circuit. Actually, it'd be interesting if I put something dark behind there, wouldn't it? Yes, it would. That's not good. Yeah, a bit of sleeving. Bit of the old sleeving. Oh no, that's alright, I think. I think we're good there. I think we have continuity. So. That's the propyl alcohol. And a squirty bottle. Gentle brush. Rinse. Spin cycle. Yeah, look at that, boys. Didn't see that one coming, did ya? That's a lovely job, that is. Turn my blower off. Make lots of nice alcohol fumes. Right, so what I'm going to do is go and get some epoxy and lay a epoxy reinforcement across that joint to hold those in position during use. But that's the first ribbon cable repaired. Now, you saw me repair this ribbon cable, and it's next morning now. And last night before I went out for dinner, I got some of the old JB Weld and put a little bit of acetone in it to make it a bit runnier because it was cold. And yeah, this is the one I soldered. So you can see now we've got a very rigid, supportive JB Weld reinforcement on both sides. Okay. Now I've buzzed the ribbon cable out, they're all connected end to end and there's no shorts, so that's one. So I've got 4 more to do. 1, 2, there's 5 in total I think have been cut. The GPIB one, the rear bus controller, the remote control ones has been severed completely. But I don't need to worry with those. I want to get the thing working first and I can patch them up afterwards or replace them. Alright, so that's it. That's the ribbon cable. That's what it looks like when it's been done. So I've got about 4 of these to join up. Now this stuff is very hard PTFE screened, double screened I think, coaxial cable. Now if this is running at gigahertz, then introducing an impedance bump, which was what a manual join in a cable like this would cause at high frequencies, or significantly high frequencies, cause the signal to bounce back down. Either way, it would cause attenuation basically. Very sharp knife. My wife has allowed me to have a knife again, and I'm just going to cut through the outer, probably about that much, probably about 15 millimeters I think should be enough. Very hard stuff. Don't like it. It's like trying to work with a piece of frozen hosepipe that's wrapped itself around the wheelbarrow and the lawnmower since you left it in the shed. How does that happen, by the way? Go back to your shed and your hosepipe has tied up the lawnmower. We just don't know. It's one of those mysteries. God, I can't even turn it. I can't even turn this. I'm going to turn that over. Let's get that to turn. Very unfriendly stuff. Now make a linear incision. Let's have a bit more light, shall we? Oh, now my tape is... fucking hell, you can't win, can you? Come on, baby. Right, so what we've got, look, is just a, obviously it's just a coax. You can see the end of it there. You can see its little end poking out. But actually, because it's such high quality military cable, there's 2 shrouds. It's got 2, can you see there's the top one pulled back there, and there's another one underneath. That one there, and this one here. So I just want to pull those back, retract it as far as I can, like that, to give me a bit of something to work with. Little knob end, look there. So let's just skin that off. And basically, as you all know, a coaxial cable is a transmission line, more or less equivalent to a uniform coupling to ground. If you imagine a wire suspended above a ground plane without any impedance, that is what a standard transmission line, and it has an inductance and a capacitance to ground, or a series inductance and a capacitance to ground. Roughly, your generator's got an output impedance the same, so the series impedance of the driving amplifier to the one end of your cable is matches the actual impedance of the cable. So for instance, TV coax is 75 ohms and usually radio is 50. I don't know what this is. And if you match the load impedance at the other end, then all the, apart from the resistive and power losses you get, all the signal you pump in one end will go out the other end rather than being reflected back into your amplifier or to your source, or from the measurement where it's coming from. So that's one end. Let's do the other end, and then we'll join these together. I had to go and get up early this morning. I was in bed, snoozing away nicely, and I had a phone call, and I had to go and rescue someone from the hospital who'd been involved in a punch-up. A random, he's a nice bloke, he's not a normal sort of person to be involved in trouble, but he was in the wrong place at the wrong time with punches being thrown. Goodwill and cheer to all men, except in Marlow, Buckinghamshire, England, High Street, on the day before Christmas Eve. So here we are, we're just going to solder these two together. To push that one down slightly. Ooh. Now clearly if you had a network and analyzer working at 1 or 2 or 3 gigahertz or even a gigahertz, you'd be able to see this and map this, and you'd actually be able to see that. You'd be able to see our joint on the analyzer, because there will be an impedance bump, right? But having said that, it won't affect us because we're only going to 1.3 megahertz maximum, and I typically use this down in the audio frequencies. But to all intents and purposes, it ain't going to make any difference because it's got that 2-pin header on the end. So now if I lift the tape off there and the dog hair, you see the mandatory labradoodle hairs. Every product repaired in this workshop comes with a free complement of hair sample from the dog. Actually, she's not that bad. She's not a labradoodle either. She'll be shocked if she knew I was calling that. She's a golden doodle. Dad was a poodle, and her mum was a slutty Labrador because she'd only just met him. Right, so here we are. We've got Kapton tape. You know this stuff. Temperature resistant, very tough, quite sticky, just won't melt, and it's an excellent dielectric insulator. So it's going to wrap some of this around the aforementioned joint. Difficult to do this so you can see it, to be honest. You have to bear with me for a moment while I give this a good. Now I'm thinking now I should have put some sleeving over this, but I think I can slide a bit over the connector at the end, hopefully, and then trink it. Okay, so that's what we've got now. Not very pretty, I have that, but maybe that was slightly too much. Maybe we'll see. Now I'm going to pull this over the top like a pullover and re-extend this braid over the top. I think I'm going to put it on 340 degrees Celsius leaded solder. Of course the Kapton is inside, and the Kapton is completely heat resistant at these temperatures, so nothing's going to melt or displace. A nice bath in lovely lead and tin flux. Okay, turn it over. And then we're going to give it a bit of a shrink. I need a shrink. What am I doing this for? I've got more important things to do, but I just want to do it. So there you have it, a joint. It's kind of flexible, look. You can see there's a straight bit obviously, but you don't want that to bend particularly anyway, because that's the rigid part where you want the connection to be. So I've got, how many more have I got to do? 1, 2, 3, 4, 5 of these to do. I'm not going to bore you with the doing of the do, shall I say. But with my sleeving out the way, you can see this one's now joined onto the output here, K1. I will do the rest. Thanks for watching, and leave me a like if you can, and also if you haven't subscribed, then hit the titty button down in the corner, because it would help to reward me for entertaining you with very lengthy and let's face it, quite boring repair in this instance.